Okay, here's number 5. Rather than drawing it like a arch, I'm going to draw it like a soccer goal. Okay, so there's that view, top view. It's going to look like that. So current's going up, to the left, and down. So here on the top view, it's going to go to the left, coming out of the page, going into the page. Is it good? Let's see how that corresponds to number 5. So here, on the right side, I'm going to grab this magnetic field around this section of wire and going like that. Magnetic field on that section of wire and going like this. Magnetic field on this section of the wire going like that. Here, going around like this. Here, it's going around like this. On top, I'm grabbing this. Underneath, it's going that way. So the compasses are just taking the path that's tangent to it. So if I were to connect the compasses, it's making a magnetic field pattern that looks like this. Oops. Ah, gross. Where this would be the north pole of this electromagnet, that would be the south pole. You okay with that? Good. All right. For today's lesson, come join me back here. All right. Really strong magnet. Okay. This far side is the South Pole. This is the North Pole. Okay. Sometimes I can get, oh yeah. Okay. So, North Pole, South Pole. Which way is magnetic field going across this gap here? This way or that way? North Pole, South Pole, and the gap outside the magnet goes out of north into south, going this way. What part of your hand corresponds with magnetic field? Fingers. Your fingers that way. Okay? Wire hooked up. Out of positive, current goes out of positive into negative. Okay? On your right hand rule, your thumb corresponds to the velocity of a particle. But if you're dealing with a wire, it's the direction of current. Okay? So we're going to stick our thumb in the direction of the current, which would be which way? This way or that way? This way. Okay? We're going to assume that we have that Ben Franklin was right, and he thought positive charge things were flowing. So if we have current going through this wire in this magnetic field, which way will this wire be forced? Show me. Magnetic field going out of north into south. Current is going out of positive into negative. Your hand should be like this. It's going to be forced. Ready? Boop. There, you see that? Okay. If you are like, if you're good with that, just ignore this next part. If you're like, wait a minute, I thought there were electrons moving. If you can't embrace Ben Franklin's convention, and it's just a splinter in your brain, listen to this. If you can't accept it, just go with it. Ignore what I'm about to say. It'll just make it more confusing. But if you're like, they're electrons, I'd say you're a realist. And electrons go in the opposite direction of the current flow. Electrons are going this way, but electrons are negatively charged in the back of the hand. Okay? You can ignore that and just go with Ben Franklin, thinking that current is positive flowing things. Okay? If you would like to feel this force, people say, oh, that's weird. That's usually the... So, grab the wire.
Is that, what if you're going to be the weaker?
Yeah. Once you feel it, you can have a seat. If you would so choose.
Yeah. It's good. Why is it being
Is it like pretty radical? Pretty sweet, somewhat.
Don't touch anybody's project but your own.
Whoa. That's interesting. You guys were just standing there.
Well, we were waiting. We were waiting for Sophie to go. Oh, wow. Pretty fun. Yep, pretty fun. Pretty lit. Go ahead, Ken. I know. Huh.
Why does it vibrate?
For other reasons.
No, I found one. So that is really one. It's like the Gen 1. The Gen 2, like, keep there.
It came out in 2020. Yeah. When did it came out during COVID? Trust me, my family threw parties. Yes, I love it.
They had some of the, those are cool.
Connor, it came out in 2020.
Which way is that wire going to be forced? Show me.
The actual music. Like on Disney Plus.
Fingers are going in the direction of magnetic field, thumbs going in the direction of current. Positive things are flowing, it's going to be forced up. Good? Figure that one out. Tell your neighbor.
So that's the thumb.
Yeah.
Our current.
Correct answer is? Fingers going to the left, thumbs going in. Hey. Good? Show your neighbor. Correct answer is? F. Field's going this way, thumb's going this way. Out of the board. Good? Correct answer is? G. Why? Going parallel to the magnetic field. No force. Okay. A huge application of this fact is how a motor works. Okay, quick terminology. Motors are electric, engines are gasoline run. Okay? This is the basic model of an electric motor. You have a magnetic field produced by this magnet. Magnetic field is going out of north into south. You have wire with current flowing through it. Okay? Which way, so the magnetic field's going down, the current's going to the right through this segment of the wire. Which way is this wire part going to be forced? Show me. Magnetic field's going down, current's going to the right. Magnetic field's going down, current's going to the right. Into the board. Good? This part of the wire. Magnetic field's going down, current's going down. Which way is this going to be forced? No force, is going parallel. This one's going to, the current's going to the left. Magnetic field's still going down. Which way is this part going to be forced? Field's going down, current's going to the left, out of the page. How is this going to move if this side's being forced into the page and this side's being forced out of the page? It will rotate. Okay? And this is designed in such a way that the current will always go to the right on top and to the left on bottom. These are called brushes, electric brushes in a motor. Okay? You stick a fan on here and you're pushing air. Good with that? Okay. Tell your neighbor. Explain how you got there.
That's where B, D, E, other F.
So it's split.
It's either A, the size of the first and that's what you do and B is the direction of the B. Those arrows are the vectors. One other option.
Yeah, but we don't want to. Yeah, we don't want
So it's going like this.
Correct answer is
It's going like this.
C. Left side, thumbs up. Field's always going to the right, into the page. Parallel, no force. Fingers still go to the right, thumbs going down, out of the page. Parallel, no force. Good? Okay. Another demonstration for you. Come on back. Okay. This is an example of an electric motor. Okay. There's something like this in any and every electrical device, whether you plug it in or you put in batteries, that has a moving part. Okay? So like a toy, or a battery operated tool, or something, some device in your kitchen, or some like device like a hair dryer, or anything that has a moving part has an electric motor. Okay? So, inside an electric motor, you're going to have the gray and the blue are the magnetic field, or the magnets in there. And then here you have a coil of wire that wrapped around an iron core that experiences that magnetic field, rotates. Okay, so on the inside of here, that's where the magnet is. Okay, these represent the yellow loop of wire. There's just multiple of them. Okay, you can pass them around, Simon. Okay. Connor. Okay. So here, these are like baby ones. Pretty cute. Dentist office, anybody? Smelling the enamel, like, ugh. Okay. The cool thing with this is, it's like a cutaway, and you can see it spin. You can see it work. Simon.
What?
Connor. Okay. This thing's pretty beefy. What? Okay. So here, if I'm going to be the brushes. Sometimes it works.
What makes you sick?
Let's start it. There it is. Oh.
Big one. Like William Thompson's.
No, right? That's what.
Spark.
That's a spark.
Magnet's a spark.
Not a spark plug.
No, it's not a spark plug.
Not a spark.
Oh.
You don't need a spark plug for an electric motor. There it is.
Mrs. Mom, you need another set of hands?
I don't know.
You need somebody to spin the tombstone.
Your suitcase.
You need me to get my call?
I was never out, so I.
Okay, if you want to see this spin.
My apologies, Adam. I got that call. Here,
Really grab onto the teeth on the bottom.
All right. More powerful. Like the more torque it has, like you can turn over. All right. Your only homework, other than the circuit project, is a pre-quiz due on Thursday. Correct.